This is the first, last, and only video in section 3.3 on cylinders. This is a very short section, and in most textbooks, cylinders and quadric surfaces are in the same section, and I could have done that in the notes, but I didn't. So I did cylinders as a separate section. So definition 81 is a definition of a cylinder. Note 82 basically says a cylinder isn't what you have always thought it is, although those things that you've called cylinders in the past actually are cylinders by definition 81. That's essentially what note 82 is telling us. And so example 83, we start with x squared plus y squared is equal to 9. Now this is a circle in the xy plane. It's a circle centered at 0, 0 of radius 3. This is the directrix of our cylinder. So this is the circle centered at 0, 0 of radius 3 in the xy plane. The generating line, or the generator, we could take the z-axis as that. Actually, any line parallel to the z-axis is a generating line. And then the cylinder is a set of all lines that are parallel to the z-axis that pass through the directrix, this curve down here on the xy plane. I've drawn this as if it starts here and goes up, but actually there's no restriction on z, so z can be negative as well. So this cylinder actually goes below the xy plane as well. I just didn't draw that part of it. But so this is a slightly inaccurate drawing. This should really go down and up. Goes infinitely in both directions. It's bounded from side to side, though, by the circle. So x has to be between negative 3 back here and 3, and then y is between negative 3 and 3. But there's no limit on the z. Now, example 84 is very similar, except the directrix is the ellipse centered at 0, 0, and it looks like this. So we start with this equation divided by 36, just to make it look more like an ellipse that we're more comfortable with. So we have x squared divided by 2 squared, y squared divided by 3 squared. That's where the 2's, the negative 2, the 2, the negative 3, and the 3 come from. Okay, so this is the directrix here. So if I were going to draw this in 3 dimensions, what would I do? I would keep the y's where they are, and then bring the x's. It would come down through 2, and then come up and make this a little bit shallower. So it would hit this point, this 2, instead of 3, but it would look very similar. It's just that the directrix would be an ellipse instead of a circle. That's the difference between example 83 and example 84. And in both of these, the generating line is a z-axis. But again, this doesn't have to be a right cylinder either. So your generating line could be something at an angle. It wouldn't have to be parallel to the z-axis. So we could take this and we could shift it a little bit this way, and it would still be a cylinder. Just might not be the thing that you're used to calling a cylinder, but it still satisfies definition 81. So again, take this and you can kind of shift it a little bit, and you still have a cylinder.